Morning, fools. Here we go. This is the lesson for Wednesday. Hopefully my son is here by now. Recording this on Tuesday. Here's your why. Go ahead and pause if you would like to read that. Here is example 1. So we're talking about greatest common factor of polynomials. So think about the greatest common factor of a number. Two numbers. So like if you had 40 and 30, the greatest common factor would be 10, because it's the largest number that can go into both 40 and 30. So if you do 40 divided by 10, you get 4. You get 30 divided by 10, you get 3. And those two numbers no longer have any numbers in common. So that's what's known as the greatest common factor. With polynomials, the greatest common factor is going to be the largest number and exponent from the variable that can go into all the terms of the polynomial. So when you look at each of these terms, the largest that can go into all of them is x to the third, because it has to be the largest but the smallest at the same time, because when you do x to the fifth divided by x to the third, you get x squared, because you subtract. X to the fourth divided by x to the third is x, and x to the third divided by x to the third is just 1. So these terms no longer have anything in common, because the 1 doesn't have an x. So when you take out x to the third, you would be left with x squared plus x plus 1. We're just going to leave that for right now, because now we have to take out a number. So the greatest common factor when we talk about a constant for these would be 2. Take out a 2. You have 6 left, 4 left, and 3 left. When these numbers and the variables have nothing left in common, that is factored and is taking out the greatest common factor. So the greatest common factor is 2x to the third, to answer the question. Try it. Find the GCF of the terms of each polynomial. If you can't see the GCF of the numbers, make a factor tree, and then it'll become obvious. This is 3 times 5, 18. It's 3 times 6, which is 2 times 3. So you pick out the number that's the same. 3. So 3 is the greatest common factor. Because the 18 doesn't have a variable, then you're done. For the second one, the number would be 6, and the variable would be y squared. You always want the leading term to get rid of a negative, so you take out a negative as well. You'd have 3y squared plus y plus 4. Ooh, that's the factor part. You didn't have to do that though. You just had to say that the GCF was negative 6y squared. That's all you had to say. Example 2. Why is it helpful to factor out the GCF from a polynomial? Consider the polynomial that guy. Well, it's useful because we're going to be factoring polynomials, and the simpler that they can be when we start, the easier it's going to be to factor them. So look at this, GCF, all those numbers have a 3 in common, and that's as big as we can go. 3, make it negative, to change the first term to a positive, and x. So consider the polynomial, factor that out, negative 3x times 4x squared plus 6x minus 9. And then this is going to be useful when we start solving solving equations using polynomials. Try it. Factor out the GCF from each polynomial. First one's easy. Just x squared plus 5x minus 22. 16, 28, and 20 would have a 2 in common. Have a 2, negative 2y to the third. Then you'd have 8y to the third, 14y, and 5y. Done. Here's your list. And that is all.